Okay, let's go to the next subtopic, terminology and units. Okay, so this is just basically to recall. Okay, so we have time, right? Amplitude, low frequency, medium frequency, high frequency. So this is one full cycle, okay, or one complete waveform. The wavelength is in one complete cycle. Okay, this is the amplitude and peak to peak here, right? So period is the time it takes for one full wavelength to pass a certain point. Frequency is wave per second. Period is seconds per wave. All right. So although this looks simple, okay, you have seen this many times every semester, even every week possibly, but it's surprised that later on during the test, during the quiz, students still make this kind of mistake. All right. Okay, never mind. That's just to recall. Next is visualization on signals, graph plotting. For that case, I need to switch to never mind. Okay, 1.3 we'll skip this later on. Let's go to 1.4 first, and then we'll go back to 1.3. Mathematical operations on signals. So example of products with unit functions. So here, this is an example where we have two functions, two different functions, and then we multiply them. Okay, this is actually quite similar to the 2 exponential negative t over 2 multiplies with ut. Right, so we have here Vt equals sine t times u t minus 2 pi. Okay, sounds complicated, looks complicated. Actually, it is not, right? First of all, we need to draw one by one. So this is the steps. You have to see the waveform one by one before you can actually combine them or multiply them to get the final waveform, right? So sine t is this, right? Towards infinity positive and towards infinity negative, right? That is sine t. Next is ut minus 2 pi. Okay, so we have this. This is our ut, right? Unit step function. And the minus 2 pi is the shift. So minus 2 pi means that shift at positive 2 pi. So this is the 2 pi. Right. So when you combine these two, sine t multiply with ut minus 2 pi, the total or the final waveform is actually, so before 2 pi is 0, after 2 pi is whatever the function it multiply. That is the sine. Alright, okay, simple as that. The sine t portion starts at t minus equals 2 pi because we have multiplied sin t by this. Okay, so before 2 pi it is 0, after 2 pi it is whatever the waveform it multiply with. Alright, next is we have this gt equals 10 exponential negative 2t multiply with u t minus 5. So straightforward, just from that we know that it is a shifted unit step function means that before 5 it is 0, after 5 it is whatever it is multiplied with. So before 5 it is 0, and then after 5 is 10e minus 2t. So here 10 is way up here, you cannot see because the scale is very small, so it's way up here, right? Very up, very far up, cannot see. Then that is the exponential decay, right? So from here to here. So you can see here, if you can recall back again, we can actually write this graph in two different ways. One is piecewise function and one is the mathematical operation or mathematical representation. Right? We can actually represent this graph in mathematical equation in this example, or in this format, or in the piecewise format, if you can recall, right? 0 for t less than 5, and then 10e minus 2t for t more than 5. So that is another way to write the graph. Next is ft for t plus 2 and a equals 1. Okay, so here g1t equals ft times ut. So ft is this, which is this, times ut. So ut means that anything before 0 is 0, anything after 0 is this ft. So simply just plot the straight line, 14 plus 2, cross at 2. This is the angle or the slope, the slope, which is 4, right? Simple. So this is for 4t plus 2 multiplied with ut minus 1. So same thing, just draw 4t plus 2, which is this straight line, but for anything before 1 it is 0. Before 1 is 0, after 1 it is the line, it is a straight line. So here and here, right? Next, x1t plus x2t. So instead of multiply or product two signals, here we add them together, right? Example, x1 is this, okay, then x2 is this. So the addition between these two will give this, right? So in this case it is a bit difficult to not difficult, it has, if you write this in piecewise function, you will have 1 2 3 4 5 6 7 function, right? So the way to do this is fairly easy. Just look at one by one every t. So at 2 we have 0, at 2 we have 2, so here 2 is 2, the total. At 1 we have 1, at 1 we have 2, so 1 plus 2 is 3. At 0 we have 2 and 3, and at 0 we have 2, so we have now this is quite confusing. At 0 we have 2 and 3, and here at 0 we have 2. So does it mean we have 3 plus 2 plus 2, which means 7? It's not 7. It is here we have 2 value. Alright, so basically we have 2 plus 2, here 4, and then we have 3 plus 2, 5. So we have 2 points. Okay, we have 2 points. And then at 1 we have 3, at 1 we have 1, so we have 4. At 2 we have 3, at 2 we have 0, so we have 3, and then that's 0, right? So multiplication, basically same concept, just look at each point one by one, try to solve one by one. Let's say for example 3 we have 0, 3 we have 1, then at 3 we have 0, right? See, 3 we have 0, and this 3 we have 1, so because it's multiplied with 0, it is 0, right? Another example, 1 we have, let's just take 2, okay, and 1 we have 2 as well, so 2 and 2 is 4, and then we take the bottom point, the lowest point. At 1 we have 1, at 1 we have 1, so it's 1, so here. Alright, next is integration of signals, also applicable to only continuous time signals. So this is basically integration. So integration of xt will get yt. Okay. Alright. Thank you. Now let's go to the next video. We will look at examples, another examples.